For this trig equation, when you look at it, you have things on both sides of the equation. So the first thing you want to do is get everything to one side of the equation. So we're going to do that by subtracting over the sine y that was on the right side. So now it's set equal to 0. And sometimes when we do these trig functions, we want to try to get all of the trig functions to be the same. So either like all sines or all cosines. And we do that so that we can factor it. But for this one, we don't need to do that because we already can factor it. They both terms already have a sine y in common. So I can go ahead and factor that out. So once we factor out a sine y, think about both of those terms are going to lose that sine y. So we're left with tan y from the first term. But even though we took out everything from that second term, we still need to have a placeholder, and that's really important when we go to solve this. So we're going to have tan y minus 1 is equal to 0 inside the parentheses. Once you get it factored, you set each of the factors equal to 0. And then you solve each one. Now this one on the left is already solved, and really we just have to ask ourselves, at what angles is sine going to equal 0? So we're going to look for our answers for that. And over here, we solve for tan. Now we have tan solved for, so we're looking for this one, at what angles does tan equal 1? If you go to your unit circle, again, you're not going to be provided a unit circle on the quiz, but you're more than welcome to sketch one if you'd like. But if you go to look at your unit circle, let's start with the sine y equals 0. So here we're looking for the angles where sine, or your y coordinate, is equal to 0. And that's going to happen here at 0. Also, it's going to happen here over at pi. So we have two answers right now for our sine function. We found that the angle was 0 and pi. And then we need to go look for tangent. Now tangent is difficult for a lot of people because it's not one of the unit or the coordinates that's right up in front, but when you look at your unit circle, there's a couple things you need to remember. Tangent is just going to be your y coordinate divided by your x coordinate. And since all of these x and y coordinates repeat throughout the unit circle, really you need to know really three main tangent values. At pi over 6, when you divide 1/2 by the square root of 3 over 2, and after you simplify it, you get that. So that would be your tangent value at all of the pi's over 6. When you go to pi over 4, and you divide y by x, you get 1, which is exactly what we're looking for on this problem, so keep that in mind. And then for the last one, at pi over 3, if you do y divided by x, you just get the square root of 3. So those are, of course you're going to have tangent values at 0, pi over 2, pi, 3 pi over 2. But those are the three ones that are going to occur the most often in these trig equations. Alright, so we're looking for where tangent is equal to positive 1. So pi over 4 is going to be one of our answers. And then if you remember, tangent is also positive in the third quadrant. So 5 pi over 4 is also going to be one of our values. Alright, so we said pi over 4 and 3 pi over, or not 3 pi, 5 pi over 4. And then the directions say give a general formula for all solutions. So if you look, 0 and pi, back on the unit circle, here's 0, and here's pi. So really to get every single value, again when you sit there and you rotate a bunch of times to get higher angles, or if you rotate in the negative direction to get negative angles, to get every single trig value, really you're only adding pi or subtracting pi every time. So the general formula for that sine function is going to be the smallest angle, which in this case is 0, plus pi. So for sine, I'll just write it up here. We had 0 plus pi times k. Remember, k is just an integer. And then for our tangent, we had tangent was 1 at pi over 4 and 5 pi over 4. Again, same situation. These make the same line on the unit circle, so really we only need to add pi to get to the next angle. So again, we're going to keep the smaller angle, which is pi over 4, plus pi k. So your final answer for this trig equation is pi over 4 plus pi k and 0 plus pi k.
Made with Doodlecast Pro.